Hello everyone, welcome to Chapter 5 of our Assembly Design Learning series. In this chapter, we will be covering 5 main sections. First up, we have component insertions, which includes both top-down and bottom-up approaches. Next, we will look at constraint modules, which is similar with the mate function in SolidWorks, but in ZW3D, is split into common constraints and mechanical constraint. The third part is basic editing, which is used for some specific manufacturing process, like second processing for welding part. The fourth part is inquiry module, which includes assembly checks and the 3D BOM feature. And the last one is explode view module. Actually, when it comes to the basic logic and the functional structure, there are not so much difference between ZW3D and SolidWorks. Let me show the assembly workflow of ZW3D through practical example. So, let's get started by creating a new assembly file. Unlike SolidWorks, in ZW3D, you can immediately rename your file after creating it and save it as you go along. Here, we will save the file immediately to make it easier for the later steps. First, let's talk about component insertion. This works a little bit differently in ZW3D compared to SolidWorks, but we can adjust settings to make it feel similar. Let's start with a small assembly model to demonstrate how to insert components. First, click on the Insert function, which is similar to the Insert component feature in SolidWorks. After clicking Insert, select the component you want. Here is a key difference. In SolidWorks, the first component you insert is automatically aligned and fixed to the default datum. In ZW3D, there's no exact same feature, but we can get a similar result. In the Placement section, click on Default Datum, which aligns the component's coordinate with the assembly coordinate, fully constraining the part. For other components that need to reference other components for alignment or constraint, we won't choose the default datum placement, but instead go for free placement. Choose the most commonly used point placement and click OK to move on the constraint setting interface. If you prefer to skip the constraint settings and just finish the insertion like in SolidWorks, you can select None in the follow-up section. Also, if you want to assembly with top-to-down approaches, you can use New to Insert function, which will create a new part with default datum constraints. Now, if you need to copy a component, unlike SolidWorks, in ZW3D, you can hold Shift and Alt and the left mouse button to drag the part, which allows you to copy and move it out. Next is the Change command, which you can change an old component with a new one. Please note that if the new component is completely different from the old one, it might lead to some constraint errors. Now, let's talk about Edit. This is actually in-place editing, which is similar to the double-clicking on a component in the history tree. To exit in-place editing, just double-click on the top assembly, and you will be back to the top level. Also, you can click the Exit button on the DA toolbar to step back through the levels. Next, let's move on to the Constraint module. This is similar to the Mate function in SolidWorks, but in ZW3D, it's split into common constraint and the mechanical constraint. Common constraints include coincident, tangent, concentric, parallel, and the middle, and also other one. Mechanical constraints cover more complex ones such as gears, path, screws, and so on. First, let's start with common constraints. It's usually better to move the components to the right position before adding constraint to avoid a mistake. You can use the left mouse button to drag parts, and also you can hold Shift and the left mouse button to rotate the components. Then you can click on Common Constraint icon or activate the command via the right-click menu. When it comes to selecting constraint objects, it's best to choose face firstly, then the lines, and the last is the points. This will make the constraint more stable. So I will show you a little sample. And here we choose the cylindrical face of this hole, and we select this one for the second one, and okay, and we keep going. Then we will select this one, and here. Okay. The last one we will select this face and this place. Okay. For angle and distance constraints, you can set fixed values or ranges. For example, here, as you can see, the constraint function in ZW3D are quite similar to those in SolidWorks. ZW3D is also very efficient in assembly. Of course, if you don't need the assembly animation, you can uncheck this option in the configuration setting. Also, if you look at the assembly history tree, you will see small icon next to the component names. These show the constraint status of the parts, which can be fully constrained, under constraint, or fixed. Next, let's talk about mechanical constraint. First up is the gear constraint. Since the gear constraint only restricts rotational degrees of freedom, it's best to assemble the gear first before adding the constraint. Once assembled, click on Mechanical Constraint and select the gear constraint. Choose the cylindrical surface of the two gears as the constraint object. You can choose to enter parameters by tooth count or ratio. The ratio can also be entered as a formula. Use the flip option to switch the parameter order if it's needed. The next example is the path constraint. This is similar to the point line constraint in SolidWorks, where you constrain a point on the component to a path sketch. Then we have the rack and pinion constraint. This involves constraining the pitch circle of the gear and the pitch line of the rack. The parameters require inputting the distance of the rack moves when the gear rotates several times, which can be calculated by using a formula. Here is the example. After that, there's a slot constraint. We can select the cylindrical surface of the slider and the interface of the slot for the constraint. Finally, the cam constraint can be done by selecting the contact surface of the two cams. Now, let's move on to the poly constraint. By selecting the outer surface of the poly for constraint, you can use the preview to check if the poly's axis and the path are correct. Then, set the belt thickness according to your needs. Next, we have the third section, which is basic editing. This is mainly for secondary processing of assembly, like adding holes or slots to welding parts. Unlike SolidWorks, in ZW3D, you need to draw a sketch and extrude a solid before using the cut command to remove material. For example, with this weld part, drawing a sketch and we will extrude it to a solid. Then, click the cut command. Select the object and decide whether to propagate feature to the components. According to the process, this part itself doesn't need this cut feature, so we won't check this box now. You can also choose it based on your own process flow. Also, you can choose to hide the cutter. Please note that after performing basic editing commands in the assembly, when calculating mass in the properties for assembly, you need to select only part in current. Otherwise, the cutter will also be included in the mass calculation. Now, let's move on to the fourth section, Inquire. The most important feature here are the interference check and the 3D bond function. The interference check helps users identify errors during the design phase, avoiding significant losses in the production stage. Click on the interference check function, select the target component or the entire assembly, and click Check to display the interfering area. The 3D bond function is also very useful. It will list the data of each component in the assembly in a table, making it easier to count or find data. The 3D bonds also support exporting to Excel or using the template, reducing unnecessary work. Finally, let's talk about Explode View. Exploded view can be manual or automatic. Manual explode view need to manually selecting components and setting them to the corresponding position, adding each explode step as you go. Auto explode involves selecting the object to explode, choosing a direction, and setting a distance, and the animation will be generated automatically according to the parameters. You can also choose whether to explode sub-assemblies. Once the explosion animation is set up, you can save it as a video and you can send it to your customer or supplier. After exiting the explode view, it will be saved in the assembly configuration. If you want to change the setting of explode view, just double-click to activate the explode view. Finally, here are a couple of tips for the assembly design. First, there is a Smart Fastener function. With this command, you can select the plane where you want to install fastener, and it will automatically add screws, gaskets, nuts, and so on. Second, when adding constraints to a complex assembly, it might be inconvenient to select constraint object. You can right-click on the component, enter Constraint Addition window, and activate the small window preview button, which will help you to select the constraint object of the component more clearly. Additionally, if the constraint object you need to select is on the inside, you can hold down the Alt key to select the interface, or you can right-click on the target object and select from the object list. And that's it for our overview of ZW3D assembly design feature. I hope this helps you to get a better understanding of how to use ZW3D for our assembly design. If you have any questions or need further clarification, feel free to ask. Thanks for watching and happy designing.